any issues between design intent, constructability, and fabrication before construction even begins. Finally, the team can also conduct 4D simulations to understand project phasing and construction sequencing, taking the project one step closer to the field. The Autodesk AEC Collection gives every designer, engineer, and contractor the tools and integrated workflows they need to deliver building and infrastructure projects with confidence. Every AEC project begins with an idea and a multidisciplinary team working with a collection of tools to bring that idea to life. Civil engineers start by developing an existing conditions model in InfraWorks. Point cloud data from recap and GIS content, such as sewer and flood information, are added to enrich the model and enable the conceptual design of road and site layouts in the project's real-world context. Switching to building design, a concept is sketched for a health clinic in the site context using Format Pro. The massing is refined, details and materials are added. The impact of sun and shadows is studied, and solar analysis is performed. Insight is used to conduct whole building energy analysis and optimization. Back in InfraWorks, the conceptual models are evaluated within the site context. Next, detailed building design is performed in Revit. The format mass is used to locate architectural elements. Dynamo is used to study alternative roof concepts through computational design. Structural and MEP engineers create models for engineering design, analysis, detailing, and documentation. The design disciplines link their Revit models to ensure the building design remains coordinated throughout the process. As the building design comes together, civil engineers develop the detailed site design in Civil 3D, including parking lot layout, grading, and drainage networks. Using vehicle tracking, even vehicle movement can be simulated and analyzed. Then in InfraWorks, a compelling visual is generated to improve understanding of the design. The next phase of the project is the design of a hospital. As before, the project moves from concept to completion with Format Pro and Revit, starting with architectural elements. Structural and MEP engineering disciplines join the project to create a highly detailed, coordinated building design. During pre-construction, design teams and contractors can perform 3D clash detection on the building and site models in Navisworks. Together, the team can identify interferences between steel framing and mechanical ducts in the building, as well as between site utility networks in the infrastructure design, enabling resolution of any issues between design intent, constructability, and fabrication before construction even begins. Finally, the team can also conduct 4D simulations to understand project phasing and construction sequencing, taking the project one step closer to the field. The Autodesk AEC Collection gives every designer, engineer, and contractor the tools and integrated workflows they need to deliver building and infrastructure projects with confidence. Every AEC project begins with an idea and a multidisciplinary team working with a collection of tools to bring that idea to life. Civil engineers start by developing an existing conditions model in InfraWorks. Point cloud data from recap and GIS content, such as sewer and flood information, are added to enrich the model and enable the conceptual design of road and site layouts in the project's real-world context. Switching to building design, a concept is sketched for a health clinic in the site context using Format Pro. The massing is refined, details and materials are added. The impact of sun and shadows is studied, and solar analysis is performed. Insight is used to conduct whole building energy analysis and optimization. Back in InfraWorks, the conceptual models are evaluated within the site context. Next, detailed building design is performed in Revit. The format mass is used to locate architectural elements. Dynamo is used to study alternative roof concepts through computational design. Structural and MEP engineers create models for engineering design, analysis, detailing, and documentation. The design disciplines link their Revit models to ensure the building design remains coordinated throughout the process. As the building design comes together, civil engineers develop the detailed site design in Civil 3D, including parking lot layout, grading, and drainage networks. Using vehicle tracking, even vehicle movement can be simulated and analyzed. Then in InfraWorks, a compelling visual is generated to improve understanding of the design. The next phase of the project is the design of a hospital. As before, the project moves from concept to completion with Format Pro and Revit, starting with architectural elements. Structural and MEP engineering disciplines join the project to create a highly detailed, coordinated building design. During pre-construction, design teams and contractors can perform 3D clash detection on the building and site models in Navisworks. Together, the team can identify interferences between steel framing and mechanical ducts in the building, as well as between site utility networks in the infrastructure design, enabling resolution of any issues between design intent, constructability, and fabrication before construction even begins. Finally, the team can also conduct 4D simulations to understand project phasing and construction sequencing, taking the project one step closer to the field. The Autodesk AEC Collection gives every designer, engineer, and contractor the tools and integrated workflows they need to deliver building and infrastructure projects with confidence. Every AEC project begins with an idea and a multidisciplinary team working with a collection of tools to bring that idea to life. Civil engineers start by developing an existing conditions model in InfraWorks. Point cloud data from recap and GIS content, such as sewer and flood information, are added to enrich the model and enable the conceptual design of road and site layouts in the project's real-world context. Switching to building design, a concept is sketched for a health clinic in the site context using Format Pro. The massing is refined, details and materials are added. The impact of sun and shadows is studied, and solar analysis is performed. Insight is used to conduct whole building energy analysis and optimization. Back in InfraWorks, the conceptual models are evaluated within the site context. Next, detailed building design is performed in Revit. The format mass is used to locate architectural elements. Dynamo is used to study alternative roof concepts through computational design. Structural and MEP engineers create models for engineering design, analysis, detailing, and documentation. The design disciplines link their Revit models to ensure the building design remains coordinated throughout the process. As the building design comes together, civil engineers develop the detailed site design in Civil 3D, including parking lot layout, grading, and drainage networks. Using vehicle tracking, even vehicle movement can be simulated and analyzed. Then, in InfraWorks, a compelling visual is generated to improve understanding of the design. The next phase of the project is the design of a hospital. As before, the project moves from concept to completion with Format Pro and Revit, starting with architectural elements. Structural and MEP engineering disciplines join the project to create a highly detailed, coordinated building design. During pre-construction, design teams and contractors can perform 3D clash detection on the building and site models in Navisworks. Together, the team can identify interferences between steel framing and mechanical ducts in the building, as well as between site utility networks in the infrastructure design, enabling resolution of any issues between design intent, constructability, and fabrication before construction even begins. Finally, the team can also conduct 4D simulations to understand project phasing and construction sequencing, taking the project one step closer to the field. The Autodesk AEC Collection gives every designer, engineer, and contractor the tools and integrated workflows they need to deliver building and infrastructure projects with confidence. Every AEC project begins with an idea and a multidisciplinary team working with a collection of tools to bring that idea to life. Civil engineers start by developing an existing conditions model in InfraWorks. Point cloud data from recap and GIS content, such as sewer and flood information, are added to enrich the model and enable the conceptual design of road and site layouts in the project's real-world context. Switching to building design, a concept is sketched for a health clinic in the site context using Format Pro. The massing is refined, details and materials are added. The impact of sun and shadows is studied, and solar analysis is performed. Insight is used to conduct whole building energy analysis and optimization. Back in InfraWorks, the conceptual models are evaluated within the site context. Next, detailed building design is performed in Revit. The format mass is used to locate architectural elements. Dynamo is used to study alternative roof concepts through computational design. Structural and MEP engineers create models for engineering design, analysis, detailing, and documentation. The design disciplines link their Revit models to ensure the building design remains coordinated throughout the process. As the building design comes together, civil engineers develop the detailed site design in Civil 3D, including parking lot layout, grading, and drainage networks. Using vehicle tracking, even vehicle movement can be simulated and analyzed. Then, in InfraWorks, a compelling visual is generated to improve understanding of the design. The next phase of the project is the design of a hospital. As before, the project moves from concept to completion with Format Pro and Revit, starting with architectural elements. Structural and MEP engineering disciplines join the project to create a highly detailed, coordinated building design. During pre-construction, design teams and contractors can perform 3D clash detection on the building and site models in Navisworks. Together, the team can identify interferences between steel framing and mechanical ducts in the building, as well as between site utility networks in the infrastructure design, enabling resolution of any issues between design intent, constructability, and fabrication before construction even begins. Finally, team can also conduct 4D simulations to understand project phasing and construction sequencing, taking the project one step closer to the field. The Autodesk AEC collection gives every designer, engineer, and contractor the tools and integrated workflows they need to deliver building and infrastructure projects with confidence. Every AEC project begins with an idea and a multidisciplinary team working with a collection of tools to bring that idea to life. Civil engineers start by developing an existing conditions model in InfraWorks. Point cloud data from recap and GIS content, such as sewer and flood information, are added to enrich the model and enable the conceptual design of road and site layouts in the project's real-world context. Switching to building design, a concept is sketched for a health clinic in the site context using Format Pro. The massing is refined, details and materials are added. The impact of sun and shadows is studied, and solar analysis is performed. Insight is used to conduct whole building energy analysis and optimization. Back in InfraWorks, the conceptual models are evaluated within the site context. Next, detailed building design is performed in Revit. The format mass is used to locate architectural elements. Dynamo is used to study alternative roof concepts through computational design. Structural and MEP engineers create models for engineering design, analysis, detailing, and documentation. The design disciplines link their Revit models to ensure the building design remains coordinated throughout the process. As the building design comes together, civil engineers develop the detailed site design in Civil 3D, including parking lot layout, grading, and drainage networks. Using vehicle tracking, even vehicle movement can be simulated and analyzed. Then in InfraWorks, a compelling visual is generated to improve understanding of the design. The next phase of the project is the design of a hospital. As before, the project moves from concept to completion with Format Pro and Revit, starting with architectural elements. Structural and MEP engineering disciplines join the project to create a highly detailed, coordinated building design. During pre-construction, design teams and contractors can perform 3D clash detection on the building and site models in Navisworks. Together, the team can identify interferences between steel framing and mechanical ducts in the building, as well as between site utility networks in the infrastructure design, enabling resolution of any issues between design intent, constructability, and fabrication before construction even begins. Finally, the team can also conduct 4D simulations to understand project phasing and construction sequencing, taking the project one step closer to the field. The Autodesk AEC collection gives every designer, engineer, and contractor the tools and integrated workflows they need to deliver building and infrastructure projects with confidence. Every AEC project begins with an idea and a multidisciplinary team working with a collection of tools to bring that idea to life. Civil engineers start by developing an existing conditions model in InfraWorks. Point cloud data from recap and GIS content, such as sewer and flood information, are added to enrich the model and enable the conceptual design of road and site layouts in the project's real-world context. Switching to building design, a concept is sketched for a health clinic in the site context using Format Pro. The massing is refined, details and materials are added. The impact of sun and shadows is studied, and solar analysis is performed. Insight is used to conduct whole building energy analysis and optimization. Back in InfraWorks, the conceptual models are evaluated within the site context. Next, detailed building design is performed in Revit. The format mass is used to locate architectural elements. Dynamo is used to study alternative roof concepts through computational design. Structural and MEP engineers create models for engineering design, analysis, detailing, and documentation. The design disciplines link their Revit models to ensure the building design remains coordinated throughout the process. As the building design comes together, civil engineers develop the detailed site design in Civil 3D, including parking lot layout, grading, and drainage networks. Using vehicle tracking, even vehicle movement can be simulated and analyzed. Then in InfraWorks, a compelling visual is generated to improve understanding of the design. The next phase of the project is the design of a hospital. As before, the project moves from concept to completion with Format Pro and Revit, starting with architectural elements. Structural and MEP engineering disciplines join the project to create a highly detailed, coordinated building design. During pre-construction, design teams and contractors can perform 3D clash detection on the building and site models in Navisworks. Together, the team can identify interferences between steel framing and mechanical ducts in the building, as well as between site utility networks in the infrastructure design, enabling resolution of any issues between design intent, constructability, and fabrication before construction even begins. Finally, the team can also conduct 4D simulations to understand project phasing and construction sequencing, taking the project one step closer to the field. The Autodesk AEC collection gives every designer, engineer, and contractor the tools and integrated workflows they need to deliver building and infrastructure projects with confidence.
Hello, good afternoon. Can you hear me? Okay, so let's get started, guys. So, good afternoon each and everyone from Luzon, Visayas, and Mindanao ng mga viewers natin. Good afternoon. So first of all, I would like to thank you all for attending sa webinar namin. I'll be your host. My name is Emmanuel Saison. Um, I am a system sales consultant from CIM Cebu branch. And for today's session is about the first episode on data-driven design workflows. So before let's proceed, ang agenda natin for this afternoon, but let's just first tackle the house rules. Okay? So the house rules, ito na. Sorry. So this webinar is recorded. If there are any of you na nagkaroon ng problema, you can access the video to the official CIM Technologies Incorporated YouTube channel within the next 48 hours. So if you have any concerns, naputol yung connection nyo, and then you want to access the video again, you can see the replay on our YouTube channel. And also, you are all muted by default. So if you have any concerns, if you have any questions, if in case of kanang mga concerns ninyo, you just have to chat that in the chat box, and then we will address that later during the open forum. And lastly, there will be an e-certificate of attendance. So it will be automatically generated to those who will attend and participate and complete the survey later. So, okay. So here are our timeline. Okay. So the webinar is scheduled for 1 hour. So from opening to the closing ceremonies, and then we also have the open forum at 2:50, and also ang pinaka main agenda natin, which is the conceptual design workflow. So in 1 hour lang yan. So if you have any concerns later, dun tayo sa open forum, okay? So let's proceed to the main topic. But before that, allow me to introduce our company, the CIM. So I'm gonna show to you our company profile. CIM Technology. Okay. CIM Technologies has been providing technology solution from software to hardware for 30 years already. More than that, we are also offering trainings, technical supports, and other expanded services for the AEC and manufacturing industries. So these are the solutions that we are offering for 3D: conceptual design, detailed design for architectural, MEP, and structural. We have also clash analysis, animations, and photorealistic renderings or visualizations, quantity takeoff, construction documents, to energy model analysis, and collaboration among project teams. Also, we have project management and scheduling for the 4D, and cost planning and estimates for the 5D, and building performance analysis for the 6D, and facility management for the 7D. Well, in case you know someone from the manufacturing solutions, from the industry, we also cater these offerings from 3D design simulation to PCB design to 3D printing, and also from the BIM management. So a lot. And also, as you can see in the right side, are software solutions like the Solid Edge. Okay. We're also offering trusted work large format printers or platters powered by HP, an industry load a leading fixed and mobile workstation by Dell. As you can see here, we have the HP and the Dell. And then if you want to set an appointment for a virtual demo sa mga plotters namin, sa mga large format printers, you may send us a message in the chat box. So aside from the software and hardware solutions, we also have our IT services. Okay, in case you have problems with your maintenance side, we can offer such as maintenance agreement, preventive maintenance for HP plotters and printers, also from the diagnosis and repairs, network design layout, to network cabling. Anything na under sa mga IT services, we also cater to that. Okay. And also, we have our expanded services. Alteon 3D provides expanded services such as 2D drafting, yes, to large format printing, to 3D BIM modeling visualization, and also to 3D printing and rapid prototyping. So if you have any concerns regarding, or if you have concerns in your company, and we can provide services such as the 2D drafting, the product designs. You can visit the website www.alteon3d.com to see other service offerings. And oops, okay. And aside from that, we also collaborated to trainings and educations. We have our training division, which is the Stanford IT Learning, to provide you basic advanced training and education in the field of the AEC, manufacturing, and power utilities industries. The good news is that our trainings are now available online, so you can pay through the website as well. So if you want to learn about the BIM tools and the best practices and the or the latest trends in related to your job role, well, Stanford IT Learning will provide you that. We had this mga CADs, mga project management, to online CAD learning. So, pag sa mga ganun, sa mga trainings, advancements, we have the Stanford IT Learning. You can visit that on the website. Okay. So the next slide, I'm humbly presenting to you our partners for the solutions and services that we're offering. As you can see, we have the Autodesk, the Siemens, the Project Pro, HP, and Dell. If you have any requirements, feel free to contact us so we can provide an assistance sa mga requirements nyo po. We also have here the Stanford IT and the Bentley. So if you have any future requirements, mga ganyan, feel free to contact. So that was our company profile. As you can see, our services there, may mga websites and our software and our solutions. So without further ado, let me turn over the screen to the main speaker of the webinar, our applications engineer Charmaine Don Esper. Siya na yung mag-discuss ng main agenda natin.
Okay, thank you very much, Eman, for your introduction. I'm gonna share my screen first. Let me share my screen. All right, can you see my screen? Good afternoon, everyone. Welcome to our first episode of Data-Driven Design Workflow. I will be the first speaker for this series, and I'm going to discuss about the conceptual design workflow. So my name is Cha. I am currently based here in Cebu City. Okay? So before I proceed to our main topic, I will share a little information about me. As an applications engineer for CIM Technologies, together with my colleagues, we are providing technical support, network licensing services, and software training to our clients. And I also have a background in structural steel connection design. And as what I've said, I am currently based here in Cebu City. I enjoy being a trainer provider, helping our students to get the most out of our training courses. So let's set first your expectations for this afternoon, right? I believe that this is not your first webinar to be that you attended in this year. I believe that you have seen a lot of great presentations about engineering services and advanced stuff like that, like modeling and analysis. But this afternoon, we are here to discuss about conceptual design and architecture. So this presentation is because every project starts with a sketch. So the design is not just a set of drawings or a model or whatsoever. The designer, mostly our architects, is a large life cycle. So we have to deal with that. So we must create and add value to our architects because they are our architects and they are our designers. So they have this big responsibility on the future of other people. And we have to provide value for that. So my presentation will focus mainly on the technical implementation of the conceptual design solutions. All right? But before that, I would like to get a feel of our audience today. We will be flashing a poll and please take time to answer. I just would like to know how many are architects, how many are engineers, be managers, owners, and so on. Okay? All right. So a few more seconds before we end this poll. Okay, so thank you for your participation. Um, don't worry if you are not an architect because this presentation is not only limited to our architects. This is also for those people who want to take advantage of our solutions which support the conceptual design workflow, right? Now, why are we emphasizing this conceptual design? So this is the first episode of our series, right? So this episode, this episode is just to say that most of the effort of our architects is at the very beginning of the project in the conceptual design phase, because it is in that phase that you can give the direction, you can give the footprint or the guidance of the project on a specific direction. So this means that our architects have this big responsibility because they are feeding technology requirements with architectural requirements, and all other disciplines will follow. Right? So I'm gonna share my screen back. Okay. Right. So this one, the design concept, this is the basic DNA of the project. Now, this is the reason why the design concept is important, because it shows the overall design intent and it gives direction for everyone on the project team. So from the early schematic design phase all the way to the detailed design phase through construction and even the implementation. So having a unified and a cohesive design concept makes all the future decisions easier. The problem we have today is that the architects are creating this design intent, but it is not maintained all throughout the project. So I believe that you would agree with that. So as the conventional design and the construction process, they are mostly relying on paper-based design with 2D drawings. There are always inaccuracies and mistakes happening because of the separate documentation, which end up with delays in the project. It also leads to losses of budget and conflicts between parties. Also, in this process, a lot of time should be spent for coordinating information and generation of documents. Now, these are the reasons why the design intent is not maintained all throughout. The question is, how do we address this, all right? We will address that with this new technology, building information modeling. This is a new innovative technology which involves an intelligent 3D model-based process which gives our AEC professionals the insight and the solutions to more efficiently plan, design, construct, and manage our buildings and infrastructure. Building information modeling is a different way of managing our building data. And right now, if you are currently using this or adapting to this technology, you will see or you will realize that this is really changing the industry from those inefficiencies that I've mentioned a while back to an integrated and coordinated process. So the overall design, so we are talking about the design phase right now. So the overall design phase, it consists of several stages. That includes the conceptualization, conducting feasibility studies. It also includes the detailed design, the production planning, and the construction detailing. And during the design phase, right, this is not only limited to our architects because it includes the coordination of our architects, our engineers, especially the structural and the MEP. So in the design process, the first player in the creation of the model, or shall we say the BIM model, is our architect. So he is the one responsible for setting up the design and for spatial planning. Then the information that he's gonna make will then be transferred to our structural engineers who add data in the model such as structural foundations or columns or floors, etc. And afterwards, the architect will complete the model with the walls and the finishing. Finally, the design is passed to our MEP engineers who design building services by adding space reservation for service roads. Now, this is about integrating the different aspects of the design. This is not merely just accommodating the demands of one designer or the other designer. So it's about combining the key aspects of each discipline into a coherent final product. This is what we call integrated design. And that leads us to Access Plus by CIM Technologies. Access Plus includes a powerful set of building information modeling solutions. Building information modeling is a concept which represents a process. Before you are going to become adapted to building information modeling, what you need to do is for you to acquire those solutions which support it. That's why we have the CIM Access Plus because it enables advanced collaboration and it activates high performance design and decision making process between our designers, our builders, and owners. Okay? So, what is included in the CIM Access Plus? Inside it is the Autodesk AEC collection. Basically, AEC Collection is a comprehensive package of solutions for CAD and BIM workflows. It also includes Autodesk flagship BIM products such as Revit, Civil 3D, InfraWorks, and Navisworks. So with AEC Collection, you can get access to a full set of software solutions to support your project needs. So we in CIM Technologies make it all available to you so that you can customize your toolset based on the unique needs of your company. Today, we won't be discussing all the solutions inside the collection because the collection has around 20 plus products. But we will just be handpicking some of them which support the conceptual design workflow for our architects, right? So let's start with the first solution. We have this Autodesk Recap Pro. I believe that there are different phases in a construction project, as I've mentioned. So primarily, when we start of the conceptual design, it is really important for us to understand what is the existing condition of our site. It could be a renovation or it could be a newly constructed project. So what we have in this AEC collection is a workflow which could help you capture the existing site condition. By the way, let's have another poll. I just would like to ask if you do have any renovation projects currently ongoing. Okay, if yes, how do you capture the existing site conditions of that particular project? Okay, how do you capture? Are you using pen and paper? Do you take pictures or do you use steel tape measurements? So this mostly these are the conventional way of capturing existing site conditions, right? Okay, so what we have in AEC collection, it allows you to capture like hundreds of pictures using your mobile phones or any camera, and then you can stitch them into a point cloud data. Okay, so we have also an option to use laser scanners. Are we familiar with laser scanners? So the one that you see on the screen right now, this is a laser scanner from Topcon, our partner. So recently we collaborated with Topcon during the online roadshow for the Philippines. Laser scanner, this is a hardware which captures 360 panoramic image of our site. And what it does is it captures everything within that site. And once you have stitched all the images which you've captured, then you will get them into the software and you will create a point cloud data. And this is what it looks like. This is not the real environment. This is the point cloud data which you can see inside the software. And what's good about this one is in the event that you want to measure something, you no longer need to go back to the site and measure, for example, the floor to the ceiling height, because you can actually do that in the virtual environment. In our case, inside Recap software. And if you are curious about aerial capturing, we can use drone to capture existing site conditions. On the screen, this is the um, this is showing the transition of technology. Before, you have to spend 40,000 US dollars for a one-time service. However, now you can have your own drone for as low as 5,000 pesos or 100 US dollars. Then the concept is the same. The drone will capture um, hundreds of photos of that site, and then those photos will be stitched inside the software. And the final output will be a point cloud data of that topographic ground surface. Then you can use this generated surface for you to develop your site and your model using Revit and Civil 3D. And you can also use this to have a better cut and fill calculations for our civil engineers. And that is how Recap Pro works. The intent of this software is to manage the captured data of the existing site condition so that you can use it with your BIM model. And the next solution we have is Autodesk Formit. In the concept design stage, I believe that sketching is one of the most important activities because the designers are trying to create a flexible and conceptual representation of their ideas. And therefore, sketches become a player of critical role in achieving a creative solution. And that begins from the stage of showing what is really going on in the mind of our architects to the level of visualizing the functional elements of our building. A lot of people are using 3D modeling platforms to visualize the concept, and at the same time, this model or 3D model provides the client with more understanding about how the space will look like in the future. And one of those modeling platforms is Autodesk Formit. So Formit is an application which allows us to draw free-form content and different shapes to start modeling and creating our geometry, very much like SketchUp. So I believe everyone is familiar with SketchUp. It also has the cartoon-like visual style and the push-pull functionalities of SketchUp. But to compare, it's more enhanced because it offers more features and functionalities. At the same time, you are inherently creating the Revit model and families, and there is an interoperability between Formit and Revit, so you can input those data directly into Revit. So these are the key takeaways of the software Formit Pro. We have the conceptual massing, conceptual modeling, and interoperability with Revit. Formit software, it comes with a free and paid version. The free versions are the one you can use on web and iOS, but the Formit Pro version, it refers to the subscription, and it is only available if you purchase the AEC collection. This subscription enables you some additional features which you cannot find on iOS and the web version. And it also enables you to update Okay. Sorry, I have to go back a few slides for me to explain. Okay, so now we are here in AutoCAD, and I believe that this is the most famous among the solutions inside the collection. So this is a drafting software application for precise 2D and 3D drawings. So updates for AutoCAD, you can now work faster with industry-specific toolsets because this software now includes industry-specific features and libraries for architecture, mechanical design, electrical design, and more. Before, um, you have to purchase because they are separate AutoCAD products previously. So for the architecture toolset, you can now speed up your architectural drawing and drafting and documentation using 8,000 intelligent architectural objects. With this functionality, you can automate your floor plans, sections, and elevations, and more, right? So you can take the power of AutoCAD wherever you go. So you can stay connected to your CAD drawings, your DWG files at job sites and in clients' offices with the AutoCAD web and mobile apps. These are now included within your AutoCAD subscription. In the web browser, you can edit, you can create, and you can view CAD drawings on any computer. So you just sign in your Autodesk account and you get to work. So there is no software installation required. Okay? And here, another update for AutoCAD. The partnership of AutoCAD with the leading cloud storage providers can simplify your workflows. So if you already store your DWG files in either of these, the Microsoft OneDrive, Box, Dropbox, and Google Drive, you can now open them directly into the AutoCAD web app. And okay, so the next solution we have for this is Revit, but we are not denying the importance of AutoCAD to the architectural and engineering sectors. Of course, AutoCAD is still the popular solution today. And a lot of longtime architects and engineers are using this software for decades now. And they are continuously adapting. I mean, the software is continuously adapting to the evolution over time. However, a new methodology is threatening the relevance of AutoCAD, and that is the rise of building information modeling. That means AutoCAD is not containing everything you need, and this has resulted in many people switching from AutoCAD to Revit. So if you are planning to switch or to transition from your 2D drawings to a 3D model in Revit, and when we say 2D AutoCAD drawings to Revit 3D model, you are probably talking about 2D or a floor plan. So I would guess that about 95% of the time, an architect will draw or sketch a 2D floor plan of the house or a building inside AutoCAD before anything starts in Revit. And that is exactly what a lot of people are doing right now. But um, you can as well start from scratch in Revit. However, if you are transitioning, that is also possible to begin your floor plans drafting in AutoCAD and transition that into Revit. So how to do that? How do you go about the transition from AutoCAD to Revit? So there is no way, it's not about converting. We are not converting a CAD file into a Revit model. What we are doing is we are linking the CAD files or importing the CAD files to our Revit project. So you will be using this CAD drawings as underlays only. So you will have to rebuild the entire building from scratch if you want a native Revit project. All right? Linked files. So we have two ways to transition. It's either using the link CAD option or import CAD option. Now, what's the difference between the two? When we use the link CAD, linked files, they retain the reference to the external CAD drawing or the files, and it will update when the Revit model is reopened or the linked file is reloaded, right? The recommendation is if your project is continuously updating, you use this link CAD option. Imported files, on the other hand, they become a part of your Revit model. It's a one-time transfer only, or it's one-time insertion. So once you import your CAD drawing inside Revit model, you will lose any connection to the source drawing. Okay? So that's why most of the time it is recommended to use link CAD, because if we are also using the import CAD option, it will result to a bigger file size because the file becomes a part of your Revit model. And this is what it looks like when the CAD file is imported or linked into our Revit project. And it will appear as a background. From there, you will have to create the 3D model in Revit. And now this is the um, Revit model created out of the underlay. Okay, so we have traced our walls, our columns, and our objects inside Revit using the underlay of our CAD drawing. Right? Next, we have is Revit. So Revit is the core of the AEC collection. This is the foundation of BIM workflows for architects. Why Revit? Because it supports integrated multidiscipline design. So it's not only limited to our architects. Revit software also includes commands or tools for our structural engineers and MEP engineers. And once you make your design changes, everything will update automatically. And you can also design with intelligent parametric objects. So that's making design changes very easily. Moreover, you can generate your floor plans, your elevation, sections, and schedules once you have completed your 3D model, and that's in automated way. And lastly, once you have created the 3D model, you can extend it for analysis or visualization, coordination, and collaboration with other project members. Right? So Revit is boasting of its feature called parametric modeling. So this is a sample representation of parametric modeling in Revit. This time we are selecting this wall in the 3D view. All right. Once you select an element in any view, in this case in the 3D view, we and if we try to move this, it's also selected, by the way, if you select in any view, it's also selected in other views. In this case, it's also selected in the ground floor. And when it comes to iterations or modifications in the design, you can also change that in real time. In this case, if we select this door, right now, the type of this door is single flush with metal frame. And let's try to modify this to become a double door. Okay, so right now it's single flush with metal frame. It's also the same in the floor plan, in the ground floor. It's a single flush with metal frame. If we change this door in the 3D view to double door, you will also notice that the change is reflected in the floor plan. And not only in this floor plan, but all other views inside the project. And that's what we call parametric modeling feature, right? So a schedule as well is a tabular display of information extracted from the properties of the elements in a project. So you can export a schedule to another software, such as a spreadsheet program like Excel, right? So you can create a schedule at any point in the design process. As you make changes to the model, which affects the schedule, all those changes will update automatically to reflect those changes. Okay? So within your building information model, contractors are able to present a visual model along with the list of material quantities which show the effect on the construction costs. And you can do this in Revit. So what makes the object in Revit intelligent is the attached data to every element. So for example, in this door, we have this door schedule. So you can include the cost of any instance and then reflect it in your schedule. And the benefits of Revit can also allow room for editing quantities. And once you make those changes, it will update and impact on the cost of your schedule. So you can benefit from these functionalities by illustrating visually in the model the quantities and related construction costs. So you can also export this schedule to any spreadsheet program. Okay, the next solution we have is concerning the underperforming buildings in the world today. So a lot of our buildings are not optimized for energy costs in a lot of ways. Buildings right now, according to a recent survey by a market research firm partnered by Autodesk, buildings are consuming around 40% of the global energy production. And that accounts for a roughly one-third of the global greenhouse gas emissions. And it's also estimated that 30% of energy in our buildings is wasted, right? That's why we have this solution inside the AEC collection, Insight. So it empowers our architects and our engineers to design more energy efficient buildings with advanced simulation engines and building performance analysis, and they are integrated inside Revit. I don't know if you're familiar with this one, but we have this 2030 challenge and architecture 2030. So the aim of this movement is to make all the new buildings and renovations carbon neutral by the year 2030. And the goal is to avoid the catastrophic effects of the climate change, which are caused by the building sector. That's why we have this solution, Autodesk Insight, to support this movement. So what does it do? So from any Revit model during the design phase, you can get an accurate picture of your building. That's gonna if you are going to give its location, given also the weather and the overall design, you can have that accurate picture. So you can use that building energy model to optimize your design. So understanding that energy model is the key to the optimization, and that is what Insight is doing. In addition to that, Insight also provides other components, just like what you see on the right of the screen: solar radiation, daylighting, heating, and cooling. Okay, so Insight is a part of Revit software. If you are using Revit, 2017 onwards, all you have to do is go to the Analyze tab of this Analyze tab of your Revit software, and then you will find there the energy optimization panel. From there, you will create your building energy model, and then you run the analysis and look into the results. So the other components of Insight, which you see here on the right area, so these are separate plugins that you have to download and install. But don't worry, because it's free if you have the AEC collection subscription. So you will get all of this for free. So this is how it appears inside your Revit software, right? So building Insight is supporting better building performance. It's cost effective, and there is no need for you to invest in additional software because it works directly inside Revit and Formit Pro, right? You can also have a real-time feedback of your model to visualize and interact with the key performance indicators. So this is not the case in other solutions. Insight is accurate and it runs hundreds of simulations in parallel to ensure its accuracy. And BIM workflow integration, because this is the only in BIM building energy model analysis tool on the market. Just like what I've said, it's working directly inside the Revit and Formit Pro software using your existing model. So you don't need to create a separate model for you to run the energy analysis, because you can do that in a few buttons. So you don't need to step outside of your BIM workflow to conduct energy analysis. There is no throwaway models with Autodesk Insight. Okay. And we have this last Autodesk rendering, although this solution is much more advanced because we're talking about conceptual design, but you can also do rendering with your concepts, and this is done inside Revit software or Fusion 360, or you can also do this inside AutoCAD. You can submit your project to Autodesk rendering from AutoCAD. So you can take advantage of extensive computing power. So thank you to Autodesk rendering, to the cloud rendering capabilities of this platform. You can create photorealistic and high resolution images in less time. Okay, so I'm gonna shift now to Revit just to give you some overview of what Autodesk rendering can do, right? So I have here Revit opened. This is a house project which I created for the training. By the way, this project started by linking an AutoCAD file which you have seen earlier into this Revit project. Then I created the model by tracing the CAD file with the elements, right? Now let's explore the Autodesk rendering plugin inside Revit. We will go to the View tab here. Okay, so by the way, for Autodesk rendering, you can submit your project or views to the cloud from Revit, AutoCAD, and Fusion 360. In this workflow, we will submit a view from this software. So you have an option here to render locally, or you can render in cloud. So this is helpful, especially if you don't have a render farm or your hardware doesn't meet the requirements for rendering. So instead of doing that locally, you will send it to the cloud. So let's click this. Okay. So here we have an option to choose a view we want to render in cloud. So it's by default, it's choosing the active view, which is the interior view of the first floor plan, right? You also have an option to set the output type. It could be a still image or a panorama image or a stereo panorama. Okay, so we will select this and we will set this to highest resolution. Okay, so you will notice here that it will require me 6 cloud credits, this one, for me to do the rendering. By the way, when you sign up for the AEC collection, you will have 300 cloud credits and you can use this for rendering purposes. And once rendering is done, you will be notified via email when you check this part here. Okay? I won't be clicking this render anymore because this particular view or this project will take about 15 minutes for this view to be completed. So I already rendered it earlier, and what I will show you next is the output. Okay, so what this platform will give you is something like this one. So you can access your, by the way, all your submitted projects in this site. So if you forget about this or you forget to bookmark this one, you just type my renderings, my gallery, Autodesk rendering, AutoCAD rendering. Okay, and this will appear. So you have to sign in using your Autodesk account, and all the projects which you uploaded to the cloud will be shown here. So I will click this project, right? So this also depends on your internet connection. Okay, so let's just wait for this view to be completed, fully loaded. Okay, so just um, just to give you information, these are some of the value-added services included in the AEC collection. So if you already have this AEC collection, you can take advantage of this particular workflow. So this is a great avenue for you to impress your clients or to win more works, and that would lead to the success of your business in the future. Okay, so let's just wait for a while before it fully loads. By the way, if you have questions, you can type in your questions in the chat box and we will attend that after this presentation. So this is what it looks like, the stereo panoramic image. And by the way, if you wish to share this view to your clients, you can show the QR code here. If you have your mobile phone, you can try it and see if it is working, right? Can you check if this is working? You just scan this QR code or you can share this via public link. Okay? If you don't have a built-in scanner in your camera, you can use Viber for you to scan this QR code. Okay? All right, so I hope that you have seen this model in your mobile phone. Now let's go back to our slide, and we only have a few minutes left before we will end this session. So I will try to make it a little more fast. Okay. So the next, let's do a quick poll again. So I want to ask if how confident are you that everyone in your project team has access to the latest versions of the project? So when we talk about the latest version of or everyone on the team, we are not talking about the consultants. We are also talking about the owner or the client or the QAs and even subcontractors. Okay? The broad spectrum of the team. So how confident are you that they have the latest information once you create changes in your project? Okay, so I hope that majority of you are confident. Okay, so now that leads us to the last topic, which is the BIM 360 for collaboration. So one of the main reasons why the design intent is overlooked is misalignment. So I have to emphasize that a successful job, it requires many different professionals to work in harmony, but this level of cooperation is very easier said than done. So for instance, a lot of structural engineers do not fully understand the design intent of our architect. So how can they deliver it? So on the other hand, if the designers are not listening to the contractor, how can they fulfill the role while remaining true to the client's goal? Okay? That is why BIM 360 cloud-based collaboration is introduced. Now, I won't be digging deeper on this topic anymore because we don't have much time. If you wish to know more about cloud-based collaboration, please follow cimtechnologies.com and register for our webinars on BIM 360 document management. And now I am opening the floor for our question and answer portion. Okay? Do you have any questions? We have a question here if the link CAD and import CAD functionality will work from AutoCAD LT to Revit LT, and the answer is yes, it works. Okay, do we have more questions? So we have a question here. I- um, what's the best functionality of AEC collection to support the conceptual design workflow? Okay, since this webinar is all about conceptual design and the primary person giving us the direction is the architect, it is a must that the design intent is maintained all throughout. And the interoperability feature of AEC collection supports this. So by using the solutions inside the AEC collection, all the data stay connected and there is no information losses when moving from one project phase to another. Okay? So I guess we don't have any more questions left on the screen. And I'm going to hand this over back to Eman for final announcements. Eman, take it away.
mean, while Ms. Cha has the time to answer these questions.
We no longer have questions left.
Okay. So thank you so much, Engineer Cha, for that insightful topic. And also to the participants, we do apologize for the um, connection interruptions a while ago. And so we thank you for your questions. And also, before we end this session, we would like to know your thoughts about the webinar by answering some surveys on the screen. So here, okay. So which software are most interested in? So you could answer Autodesk AEC Collection or the Autodesk BIM 360. Also, you could here in the question number 2, um, what are the tools inside the Autodesk AEC Collection might be useful to you? Check all that applies. We have the Revit, we have the Navisworks Manage, we have the Civil 3D, and we also have the AutoCAD. And on the third question, are you interested to enroll for our online training to learn Autodesk software? So if your answer is yes, I'd like to enroll soon, or no, I'm not interested to enroll soon, or no interest at all. So the fourth question, how satisfied were you in the webinar? Very satisfied, you will be satisfied, somewhat satisfied, or dissatisfied. And on the fifth question, how relevant is the topic to you? Is it very relevant the way Ms. Cha discusses the workflow? Is it relevant, somewhat relevant, or irrelevant? And on the sixth question, how do you rate the speaker, Ms. Engineer Charmaine? She's very good, needs improvement, or poor. And also any topics you would like to learn in the future. Possible we will conduct future webinars on that topic. So just type your opinions, yeah, any topics that you would like to discuss in the near future. Okay. So I'm guessing that everyone's done answering. So, okay, what do you have here? Well, as you can see in the, sorry here. So thank you for participating in the survey. Your responses are valuable to us and we will definitely consider your feedbacks in the future. So let us also share with you our upcoming webinars. You might also invite your colleagues or your boss to join this webinar. So here, so we have here that, so we're inviting you to join the webinar series on data-driven design workflows on bridge design workflow on December 10, yes, at 2 p.m. to 3 p.m. And also the generative design workflow at January 21, 2021, 2 p.m. to 3 p.m. also. So feel free to register in advance and share the link as well to your colleagues or your boss, so they will be registered in the webinar. And also on the screen is our product update webinar series. So feel free to join What's New in Civil 3D if you're into Civil 3D and InfraWorks 2021 on December 17, and What's New in AutoCAD 2021 on January 14 next year. So register through the link that was sent to you in the chat box. As you can see, there's a link on the chat box. And also, I think we come to an end to this webinar. Once again, thank you, and we look forward in seeing you to the future webinars.